Yeah, hello children. In our previous class of acid, base and salts, I was able to discuss only acids, and that also I could not complete. Acid, in fact, one more part which is there in the syllabus is still left, that is properties of acid. I discussed with you the definition of acids. We discussed the classification of acids. I think these are the two things that we had done: classification and the definitions of acids. And then I told you in detail about how to categorize, how to understand whether a given substance is an acid or a base or a salt. Alright, now moving further, now with respect to the previous topic that we had done, now our next topic actually is properties of acid. Once we finish with the properties of acid, we have finished with acid, then after that we will start with base and then finally salt. Alright, then here we go, properties of acids. Now when you say properties, here generally we will discuss about the properties, general properties of dilute acids. Now you know already in the previous class when we did classification of acid, we discussed about what is dilute acid and what is concentrated acid. So it is all about the quantity of water that we add. The more the water quantity, if water quantity is more, then we call it dilute. If the water quantity is less and acid quantity is more, then we call it concentrated acid. So then our dilute acid properties, so that means here I am going to discuss about 5 different properties of acid. Then in addition to that, maybe I will discuss 2 more which is applicable only for certain acids, only for concentrated acid or only for a certain nitrate. But then 5 properties which I am going to discuss now is what is applicable for 5 different places in your syllabus. For example, where are the 5 places? Same property you are going to learn in this chapter, acid, base and salt. You are going to learn the same thing in the chapter which will come in future, that is hydrogen chloride or hydrochloric acid. Same properties you are going to learn. Then nitric acid you are going to learn the same, sulfuric acid you are going to learn the same, and finally in organic chemistry you are also going to learn about acetic acid. There also you are going to learn the same property. That is why what I am going to mention here, or what we are going to discuss today, is something which is applicable at 5 different places in your book. So that is why learn it properly. If you learn it at one place, that means you have all done the preparation at 5 different chapters of your book. So that is why this is very, very important. But since I wrote the heading as properties, let me discuss physical properties as well as chemical properties. Physical property of acid, I think I discussed already with you last time. Now if you are talking of air, let me not mention the physical property. I will just verbally tell you about how do they smell, what do they test, or what is their test, in fact what is their appearances, colors. Now the first thing I should tell you that acids are either solid, as I told you in the previous class also, solid. For example, boric acid is solid, oxalic acid is solid. So acid can be solid also, it does not mean that acids are only liquid, or most of the acids are liquid. So either solid or liquid, no gases, we do not have any acid which is in the gaseous form. So in terms of physical property, acids are either solid or liquid. Then in terms of test, I think we discussed about tests. All acids are sour to test, they are very sour. Yes, some acid can be tested, for citric acid, lactic acid, but then you know all acid cannot be tested because they can be dangerous. Sulfuric acid, hydrochloric acid cannot be tested, TASTED, tested. Whereas, yeah, if it is tested, but it is sour. So, but as such does not mean that again acid should be tested. So, but all acids are sour to test. Yeah, they are corrosive in nature. Now when I say corrosive in nature, you know that they can be dangerous. For example, when sulfuric acid is coming in contact with your hand, you know, it burns the skin, you know, it makes your skin black, charred skin you will have. Then next one is your nitric acid. Nitric acid, when it comes in contact with your skin, you know, it makes your skin yellow. You know, then again similarly hydrochloric acid, it makes your skin amber color. So you know, it is all about the reaction which is taking place between the acid. So that is what is corrosion. Corrosion means can be dangerous, can affect your skin. So these are some of the properties. Now with respect to other property, now if I also tell you, maybe yes, if I tell you this word, maybe it becomes a little difficult for you to understand. Acids, not only acid, later on in the base also I will say the same. Acids are very good electrolyte. Now what is the meaning of electrolyte? In your chemical bonding chapter, we discuss about something called ionic compound and covalent compound. Ionic compounds can form ions. So electrolytes are those compounds which either in aqueous solution or in molten state, when you are adding water or when you are heating it so much that it melts, In that particular state, they form plenty of ions. That is why acids are very good electrolyte. For example, sulfuric acid is a very good electrolyte because it ionizes, it forms a lot of ions. Similarly, all acids, not only acid, even bases, alkalis, they are also very good electrolytes. So that means one property that we can say about acids are that they are all very good electrolytes. Now these are all very minor property, physical properties, so that is why I am not mentioning it here. Now as I said, very important properties of acid is what I am going to, and then yes, the top 5 which are there are very important. As I go from 1 to 5, this property treat it as very important. Alright then, what is the first property of dilute acid? So again I am mentioning it is dilute acid. All dilute acid, whether it is hydrochloric acid or sulfuric acid or nitric acid, they will react with a base. All acids react with a base to give you salt and water. So you have heard about this reaction before also. This reaction is what is called neutralization reaction. Neutralization. Acid reacts with the base to give you salt and water. Okay, let's take one example. So by the way, this reaction you can write for any acid and any base. Yeah, I'll just pick up only one reaction. Here, let me take one acid. Yeah, hydrochloric acid. Let me take one base. The most common base here, I'll take sodium hydroxide. So acid is this one, base is this. Now when acid reacts with the base, the product is salt and water. Salt means now they will exchange the radical. Sodium will go and join with chloride to form sodium chloride there, and the H will go and join with OH to form water. Yeah, this is what is property number 1, and this property is also applicable for bases. Later on when you go to bases, when I discuss with you the property of bases, the same property is what I am going to discuss with you, because this is the property of base also, number 1. Number 2, all dilute acids will react with metallic carbonates and bicarbonates. Whether it is carbonate or bicarbonate, it really doesn't matter, because the reaction will be the same. Only that balancing part, when you are doing the coefficient that in front of the chemical compound, only will be different if it is a carbonate or bicarbonate, or its product will be same. Then what it will give you? It will give you one salt, then it will give you water, and since it is a carbonate and a bicarbonate, it will give you carbon dioxide gas. Carbon dioxide gas is what is produced, and this carbon dioxide gas, as you know, is what is tested by lime water. Lime water is turned milky by this gas, carbon dioxide. Okay, let's take one example then. Let me take one metallic carbonate. Okay, let me take one acid. Let me take sulfuric acid. This is dilute sulfuric acid. If I react with one carbonate, let's take calcium carbonate. Any metal, you can take any metal, calcium, magnesium, aluminum, whatever like, you can take that, any carbonate. Or if you like, you can write here bicarbonate also, here calcium bicarbonate. So instead of carbonate, you can write bicarbonate, because here whether it is a bicarbonate or a carbonate, is the same reaction is what will take place. Then the reaction between the two is what will yield a salt. Now with salt, your calcium will go and join with that sulfate to form calcium sulfate. Yeah, this is the salt. Now I don't have to tell you what is salt, because in the previous class I have already discussed with you what is salt, or how to recognize from the formula whether it is a salt or not. Here you can see a salt plus the other two is what is fixed, water and carbon dioxide. So water plus carbon dioxide. This is what is the second property of acid. So acid will react with metallic carbonates and bicarbonate to give you salt, water and carbon dioxide. Now next one, a very similar reaction is this number 3 with number 2. Number 2 and 3 are very similar. That was carbonate. Now here we will discuss about sulfide. Dilute acid will react with a metallic sulfide or a bisulfide. So there you are. Previously it was a carbonate and bicarbonate, now it becomes a sulfide and a bisulfide. To give you, very similar one, a salt, as you can see there, salt, here also it is salt, plus water, and then since it was a carbonate, that is why it was carbon dioxide. Now since it is a sulfide, it will give you sulfur dioxide. So the only difference is in the gas which is produced. So there carbon dioxide gas is produced, here sulfur dioxide gas is produced. I said carbon dioxide is tested by lime water. Lime water is turned milky. Sulfur dioxide actually turns potassium dichromate solution green. this gas, when you are passing through potassium dichromate solution, it will be turned green. So this is tested, sulfur dioxide is tested with potassium dichromate solution. Alright, now let me write one reaction then. Okay, let me take a nitric acid here. When a nitric acid, take any acid, any dilute acid, and usually when you talk about dilute mineral acid, we either take a hydrochloric acid or a sulfuric acid or a nitric acid. So let me take as an example, if you like, you can write here sulfuric acid, hydrochloric acid, whatever you like, you can write. Now let me take one metallic sulfide. Let me take zinc sulfide or zinc bisulfide. Yeah, like how bicarbonate, here I can write zinc bisulfide also. Now the reaction between the two is what is going to yield a salt. Salt will be zinc and nitrate. Zinc will combine with this one to form zinc nitrate. Here it is, zinc nitrate, zinc valency 2, so that is going down, nitrate valency 1, zinc nitrate, and the other two is what is fixed, it is water and sulfur dioxide gas. So the sulfur dioxide gas, how to test, I have already said, potassium dichromate solution is turned green. 1, 2, 3, 2 more. The fourth one, dilute acid reacts with a metallic sulfide. Yeah, that was sulfite, ITE, SO3. This is sulfide, S. So metallic sulfide to give you a salt and S2S gas. There is no water here. Almost in all reaction I wrote water, but this is a reaction where water is not produced. In fact, a gas is produced, S2S, hydrogen sulfide gas. Alright, now let me take one acid again. Yeah, let me take hydrochloric acid. And let me take one sulfide. Let me take sodium sulfide. Sodium sulfide, sulfide symbol S. This is going to give you a salt, NaCl. You can see sodium is going and joining with that to give you NaCl, and plus this hydrogen is coming to join with sulfide to give you H2S. Now this hydrogen sulfide gas is recognized by its very bad smell. The smell of this gas, hydrogen sulfide gas, is what is called rotten egg smell. Rotten egg smell. So if you see somewhere in the question rotten egg, then immediately you have to think about this gas, hydrogen sulfide gas. It smells very bad. Now how do we test hydrogen sulfide gas? I told you the chemical test of sulfur dioxide, I told you the chemical test of carbon dioxide. Same way hydrogen sulfide also can be tested. Now hydrogen sulfide is tested by lead acetate. Like what you do, take a filter paper, dip the filter paper in lead acetate solution. Lead acetate solution. And when this gas comes in contact with that filter paper which has in it a lead acetate solution, then the filter paper turns shiny black. So if you are asked how to test hydrogen sulfide gas, you will say lead acetate paper is turned shiny black. Shiny, you will see the paper becomes very shiny but black in color. So that is how you test hydrogen sulfide gas. Again, one thing is that it smells very bad, rotten egg smell, and the other one is that the chemical test is that lead acetate paper is turned shiny black. So 4. Then I was telling about 5, so I finished with 4. Now the fifth one. The fifth property of acid is all dilute acid will react with active metal. Now when we say active metal, you have learned metal activity series in class 9, also in class 8. Metal activity is arrangement of metal in descending order of their reactivity. Now what is the meaning of active metal? Active metals are those metals which are above hydrogen in the activity series. So that means there are very few metals only which are below hydrogen. Now what are the metals which are below hydrogen in the activity series? Below hydrogen you have copper, mercury, silver, gold, platinum. These are the only metals which are below hydrogen. Rest all the other metals are above hydrogen in the activity series. So that means active metals are those metals which are above hydrogen. So that means any dilute acid reacts with active metal, because active metal, those metal will be able to replace hydrogen from acid. So because hydrogen, we are here talking about active and passive metal or active and non-active metal. So those metal which are below hydrogen cannot replace hydrogen, but this active metal can replace hydrogen to give you one salt and hydrogen gas. So the almost everywhere gas is produced. Gas. You can see all our gas is producing. So hydrogen gas, you know how it is tested. Hydrogen gas is tested by the pop sound, glowing splinter. When you put into a environment where hydrogen is there, it gives you a pop sound. Hydrogen is tested that way. Now this is the only property, the fifth property is the only property which is not followed by nitric acid. And nitric acid will not show this property. Yeah, hydrochloric acid and all other acid will show, but except nitric acid. So now I'll tell you why nitric acid cannot, because nitric acid being a oxidizing, very good oxidizing agent, will not be following this, because whatever hydrogen is produced, it will be oxidized to water. That is why this is the only exception for nitric acid. In nitric acid chapter also you'll learn about this reaction. Nitric acid, you have a chapter nitric acid, there you'll discuss. Now let me take one example then. Yeah, sulfuric acid, if I am taking as a dilute acid, active metal. Now think of any metal above hydrogen in the activity series, any. Okay, I'll take zinc. In the activity series, since zinc is more reactive than hydrogen, now this zinc will go and replace hydrogen. Now when I say replace, to use the word properly, I think it should be displace. Hydrogen will be displaced by zinc. Zinc will be able to kick out the hydrogen from there. So as zinc will go and take the place of hydrogen, so here it forms zinc sulfate. You can see a salt. Zinc sulfate is a salt. And since hydrogen is kicked out, there it is, hydrogen gas is what is reduced. And again I am repeating, this reaction is not shown by nitric acid. Hydrochloric acid will show, sulfuric acid, all other dilute acids show. Nitric acid is the only acid which will not show this reaction because of its oxidizing property. So these are the 5 properties which I was telling you, very important. 5 different places in your book you will come across these reactions. 5, again I am repeating, 5 different places. Now I am moving aside, you can take the screenshot, save it, to learn what exactly these properties are. So here they are the 5 properties. So take the screenshot and save it, it will be, and then also if you want, note it down in your copies. This is what is your very important properties of acid. 5 different places in your book you will come across these properties. Now in addition to these 5 properties, you also have some other additional properties, but that is for a very few compounds. You will see now I have written already 5. Now since I don't have space, I will the 6th one is with respect to nitrate. Now what about dilute acid and nitrate? As such, dilute acid and metallic nitrate, they don't react. There is as such no such a sequence like how we have been writing. You will not find for nitrate. This reaction does not take place. But there is a special nitrate, and that also for a special acid, HCl, that is hydrochloric acid and sulfuric acid. And here I am talking about dilute hydrochloric acid and dilute sulfuric acid reacts with one nitrate, that is lead nitrate. You will understand this reaction better when you do salt. You will see that in salt there is something which is called insoluble salt. How to know which salt is soluble in water, what is not soluble in water, you will understand it better. Now I will just write the reaction only, but when you finish salt you will understand why or how this reaction is taking place. Now whenever, don't forget this is a soluble salt, nitrate. You will see later that nitrate is, all nitrates are soluble, even lead nitrate is soluble. When the reaction between the two takes place, if hydrogen chloride or hydrochloric acid, if it reacts with lead nitrate, then it will form lead chloride, PbCl2. So exchange, Cl will go and join with P, and H will join with nitrate to form nitric acid. Here you are. And this lead chloride is an insoluble salt. So the arrow down means precipitate. So insoluble salt is produced. Same way, if it was sulfuric acid reacting with this, then you give you lead sulfate, PbSO4. Again this Pb joining with sulfate and hydrogen joining with nitrate. So again lead sulfate is also an insoluble salt. A precipitate is formed, and then plus here also it is nitric acid. So that means only these two, that is sulfuric acid and hydrochloric acid, reacts with lead nitrate. See why I told only 5, even the 6th one is there. Why I said only 5? Because this is only specific for these 2 acids only, and that also only one particular nitrate. Actually there are some more nitrates also, like for example silver nitrate, mercury nitrate for chloride, and for sulfate other nitrates are also there. But then generally this lead is what is applicable for both. That's why we say lead nitrate is the only nitrate which reacts with these 2 dilute acid to produce insoluble salts. Then next, the 7th and the last. Now this is, since our heading is property of acid, till now I had been discussing about properties of dilute acid where a lot of water is present. Now the 7th one is the property of concentrated acid. So concentrated acid, especially sulfuric acid, reacts with metallic chloride. So whenever concentrated acid reacts with the metallic chloride, and then when I say concentrated acid, especially you'll see this as the lab preparation of nitric acid and hydrochloric acid. So this is what we follow. This reaction is what you'll see in hydrogen chloride chapter as well as also in nitric acid chapter, that this is the method of preparation of nitric acid and hydrochloric acid. So concentrated sulfuric acid when reacted with, now let me take one metallic chloride here, sodium chloride. Others will not react. But then this is a specific concentrated acid with this particular metallic chloride. Then the reaction between the two is what is going to give you a salt. Yeah, temperature is very important here. So if you heat it above 200 degrees Celsius, something else is produced, and if you heat it below 200 degrees Celsius, something. So, and then you will see in the lab preparation in those chapters which will be coming in future, we heat it below 200 degrees Celsius. So if you heat this below 200 degrees Celsius, then it will produce a compound which is sodium bisulfate, a salt. So sodium bisulfate is produced, and then plus HCl. Here you are, HCl. Supposing if you are reacting this with sodium nitrate, then it will produce here nitric acid. So I reacted with chloride. Chloride will give you HCl, and nitrate will give you nitric acid. So this is what is a lab preparation of HCl and nitric acid. So these 7 properties that I discussed are the properties of your acid. With this we have finished with acid. What we have discussed about acid, we have discussed the definitions. In fact, I gave you the introduction about all acid, base and salt, how to recognize them. Then in acid we discussed classification of acid. Preparation of acid is not there for this chapter, but then when you go to other chapters where acids are there, like hydrogen chloride or hydrochloric acid, nitric acid, sulfuric acid, acetic acid, there we will do the specific preparation of those acids. But here general preparation of acids we are not discussing, not in your syllabus also. And properties of acids we have finished, both physical properties I discussed as well as also chemical properties. With this we are winding up with acid. Now our next topic is base. Okay, let's start with bases now. Now what are bases? Now how to define a base? Bases are metallic oxides. Okay, here it is. Either it is a metallic oxide, metal, you know what are metals, so any metallic oxide, like for example copper oxide, zinc oxide, so many metals are there, so anything oxide. It may be a metallic oxide or it may be a metallic hydroxide. So that means, since I said copper oxide, then same thing you can include copper hydroxide, zinc hydroxide, magnesium hydroxide. So either a metallic oxides or metallic hydroxides. And also one more thing, it can also be ammonium hydroxides. So now when you define it only, you will have to take the name of these 3. So it may be either a metallic oxide or a metallic hydroxide or ammonium hydroxide, which reacts with hydronium ions of the acid. Now you know that since acid contain hydronium ion, we discussed already in acid part, hydronium ion. So this basis reacts with hydronium ion of an acid to produce salt and water only. So it is very, very important that you have to mention that it should be salt and water only, because other than salt and water, if some third product is produced, then it is not considered as a base. So again, let me define what it is. Now again, for the last time, what are bases or what is base? Base are metallic oxide or metallic hydroxide or ammonium hydroxide, which reacts with the hydronium ion of an acid to produce salt and water only. Okay, that means if something is considered as a base, okay, let me go with any metallic oxide. Okay, copper oxide, copper metal oxide. It must react with an acid, that is hydronium ion of an acid. So here, even though I am showing hydrogen, but when it is mixed in water, it forms hydronium ion. So this base reacts with acid to produce salt. You can see copper chloride, copper will go and join the chloride, and the other one is what is water, H2O. So this, you can see only 2 products are produced. One is a salt, this is a salt, and the other one is water. If one more third product is also produced, then we will not consider this as base. So now this is fulfilling the criteria of a base. So bases are compounds of metallic oxide, metallic hydroxide or ammonium hydroxide, which reacts with hydronium ion of an acid to produce only salt and water. This is what is base. But usually when we say base, so as we discuss about metallic oxide, metallic hydroxide, then we may say something like basic oxide, and the other one is basic hydroxide. So as the name itself is suggesting, basic oxide. This example which I gave you was about basic oxide here, copper oxide, or the same thing I can write about copper hydroxide. So basic hydroxide. So then when you define a basic oxide, how do you say? So basic oxides are those metallic oxide which contain oxide ion. You can see the ion which is present here is an oxide ion. Then what happens to this? This very metallic oxide reacts with the acid to produce salt and water. Again the same reaction I can write here. I can reacting with an acid. Here I wrote HCl, now let me write sulfuric acid. So this metallic oxide which contains oxide ion may react with acid to give you only salt and water. So do not forget, other than salt and water you should not have the third product. Similarly, what are metallic hydroxide? Then again I'll say your basic hydroxides are those metallic hydroxide which contain hydroxide ion. There I said oxide ion, here I am saying hydroxide ions which contain hydroxide ion which reacts with the acid to produce salt and water. So copper hydroxide also, if I react with, let's suppose one acid, any acid, then it will give you a salt, so here, and then water. So only salt and water is what is produced. Now please note that every metallic oxides or hydroxides are not base. Okay, like for example, one very good example I'll give you. There is something which is called lead 4 oxide. Lead 4, I mean to say Roman 4. Yeah, PbO2. Here valency of lead is 4. So that 4 has gone there, 2. Oxide is 2. So 2 and 4, as you cancel it, this is what is lead 4 oxide. This lead 4 oxide, when you are reacting with an acid, okay, here, is this really a base? Now we are going to discuss whether this is a base or not. Is it a base or is it not a base? Now if this is a base, then it must react with acid to give you salt and water. Okay, let's see then. When lead 4 oxide is reacting with HCl, then it produces a salt. Salt is PbCl. Here it is. It produces a salt, and it also produces water. So it produces salt and water. But in addition to this salt and water, it also produces one more product, and that is chlorine gas. Chlorine gas is also coming out. Now I can't say that this is a base. This is not a base. Why it is not a base? Because every time in the definition I said as a product it should be salt and water. But here in addition to salt and water you have one more, that is chlorine product is also there. So that is why, since it is not fulfilling the criteria of a base, because bases are those which should react with the acid to give you salt and water only, but here one more is there. So that is why don't think that all metallic oxides are bases. Here is in one example of metallic oxide. Even though it is a metallic oxide, it is not a base because it is not fulfilling the criteria of a base. This is what is about acid. Acid we have finished. This is what is about base. So definition of base. Then again I categorize base as basic oxide and basic hydroxides. Then I think here I should also tell you about something which is alkalis. Now what are alkalis? Alkalis are soluble base. So alkalis are soluble bases. So alkalis are those bases which are soluble in water. So if any bases which are soluble in water, then they are considered. Now then if you ask me, sir, then what are alkalis? Yeah, again you'll be understanding better when you go to salt part, when we do solubility chart. A salt part is a very lengthy part. I think today we will be winding up with acid and base, and maybe in the next class we will discuss salt. That also I think whether I will be able to finish in one class or not, because that is very lengthy part. So yeah, sodium hydroxide is base, and this base is soluble in water. Now again if you ask, sir, how to know which is soluble and what is not soluble? Wait for some time, because as we do salt, there you will understand how to know which salt is soluble and what is not soluble. So this is a soluble base. Potassium hydroxide, a soluble base. Calcium hydroxide is a soluble base. It is, even though not very much soluble, but then sparingly soluble. Then ammonium hydroxide. Yeah, these are the bases which are soluble in water. That is why we consider them as alkalis. But then again, this alkalis also now later on when you go to classification, like how we did classification of acid, same way now we will classify bases. Our next topic is classification of bases. There we will talk about strong alkalis, weak alkalis. These are considered as strong, these are considered as weak. Okay, I think let me go to the next topic. By the way, what is the meaning of alkalis? Alkalis are bases which are soluble in water. And yes, going on to classification of bases. Okay, here only I will discuss now. On the basis of the strength, an acid, a base may be considered as a strong base or a weak base. A base is considered as a strong base which when dissolved in water produces plenty of hydroxyl ion. Hydroxyl means OH ion. Hydroxyl. In acid we said strong acid is that which produces plenty of hydronium ion. Hydronium for acid, hydroxyl for base. So that means KOH and NaOH, this when you dissolve in water produces plenty of so much hydroxyl ion, that is why we consider them as very strong alkalis, strong bases. Whereas these two when dissolved in water produces very less. So less number of hydroxyl ion, this produces plenty of, these two produces plenty of hydroxyl ion, that is why they are strong bases or strong alkali. Whereas these two are considered as weak alkalis because they produce very less hydroxyl. Yes, they will also produce hydroxyl ion. They will produce hydroxyl ion, that is why they are bases or they are alkalis. But the amount of hydroxyl ion which they produce is very less, that is why they are considered as weak. Then the second classification, first one is strength and the second one is in terms of acidity. If you remember, in acid we had said basicity, and now in base we will say acidity of a base. What is the meaning of acidity? Acidity is the total number of hydroxyl ion produced when one molecule of the base dissociates. Okay, for example, when NaOH is breaking into ion, so it will produce Na plus and OH minus. Now this is a balance equation. You can see for one molecule of NaOH only one OH is produced. That is why we say the acidity of NaOH is 1, or we say it is a monoacidic base. Mono. So from the formula only you can find out. You can see in the formula OH only 1 is there. That is why here its acidity is also 1. Same way if I am going for the second one, calcium hydroxide. When it breaks into ion, it will form calcium ion plus hydroxyl ion. But to balance this equation, I have to write here 2 in front of OH. So that means for one molecule of calcium hydroxide, 2 OH ions are produced. That is why we say acidity of calcium hydroxide is 2. Again, don't forget, in acid we had seen basicity. In basicity we count the number of hydrogen ion or hydronium ion produced. Here we have to count the number of hydroxyl ion produced. Similarly, if I am going for aluminum hydroxide, in aluminum hydroxide it will give you aluminum ion and hydroxyl ion. But to balance it here, 3 are there, so I have to write here 3. So then we say that acidity of aluminum hydroxide is 3. So it is very easy. Now if you are asked to write about the acidity 1 or 2 or 3, just think about the formula, think about the valency. Sodium has a valency of 1. So when you are writing, so 1. Calcium, magnesium, zinc, they have a valency. You can write any hydroxide. Zinc hydroxide also will give you 2 because they have the valency of 2. Aluminum valency 3. So you can write other metal also which has valency 3. So which will give you 3 hydroxyl. This is what is a classification of base. Now moving further, we will discuss now about the properties of base. How we discuss about the properties of acids, same way we will also be discussing about the properties of bases. Now I am going to properties of bases. Even though we may say properties of bases, but more so 4. We are not going to see too many like acid. Acid we saw 7 of them, but here we are going to see only 4 of them. 4 properties of bases. More than bases, it is a properties of alkalis. You know alkalis are also bases, so don't forget that. You may come across a sentence where it is written all alkalis are bases, but all bases are not alkali. Obvious, because every bases are not soluble. Those insoluble bases are only bases. We cannot call them alkalis. But all alkalis are bases because those bases which are soluble in water are alkalis. So that's why the very common and popular phrase they use is all alkalis are bases, but all bases are not alkalis. The meaning is that because every bases are not soluble in water. Coming on to properties of bases or alkalis. Again I am repeating, even though I might have written bases, but almost all 4 properties that I am going to discuss is actually the properties of alkalis, soluble bases. The first one, all bases, whether it is alkalis or simply bases, insoluble bases, react with an acid. I told you when I discuss about acid property also, that we will come across the same property in base also. All bases will react with acid to give you salt and water, neutralizing reaction. So you know this is a neutralizing reaction. You can write any base. Okay, let me take any one base. So let me take potassium hydroxide, or you can take copper oxide, zinc oxide, any metallic oxide you can take, or acid. Let me take sulfuric acid. So as base and acid will give you salt. Salt means potassium will go and join with sulfate to form potassium sulfate, and then plus water. Yeah, this is the first property of base, which you know already. Second one, alkalis have the tendency to absorb carbon dioxide. In fact, you might have heard about caustic soda, caustic potash, especially caustic potash is used for absorbing carbon dioxide. In that year photosynthesis experiment in biology you might have seen. So caustic potash is nothing but an alkali. So that means what can alkali do? Alkali can absorb carbon dioxide. But now when I say absorb, it may sound like a physical property, physical reaction, but actually it is a chemical reaction taking place. Here it is, alkali, potassium hydroxide or sodium hydroxide you have to take, and when carbon dioxide come in contact with this, then see what exactly are the product. Potassium will go and join with carbon to form potassium carbonate. Here it is, carbon dioxide absorb and form carbonate, and then here water, H2O. So that means the second property of alkali is that alkalis have the tendency to absorb carbon dioxide from the atmosphere. And don't forget, acid has the property of liberating carbon dioxide. You saw that second property of acid when I said acid reacts with carbonate, metallic carbonate and bicarbonate to liberate carbon dioxide. Carbon dioxide was there on the right side. But if you look at base, property of base has carbon dioxide on the left side. It is absorbing carbon dioxide. So there is a difference between liberating and absorbing. So this is absorption. In acid it was liberation of carbon dioxide. So this is what is your second property of alkali. And the third property of alkali is all ammonium salts. Okay, I think I'll write rather alkali first. All alkalis will react with ammonium salts. Now when I say ammonium salt means it may be ammonium phosphate, ammonium chloride, ammonium nitrate, whatever. Second part can be anything, but first part it has to be ammonium something, ammonium chloride, to give you a salt, water, and then plus ammonia gas. In fact, you will see in ammonia chapter, this is our lab preparation of ammonia. When you are asked to prepare ammonia in the lab, this reaction is what you use. Again I am repeating, for the lab preparation of ammonia. Then let's take one example then. Let me take that same lab preparation of ammonia. In ammonia lab preparation we use calcium hydroxide as an alkali, and we use ammonium chloride as the ammonium salt. So when an alkali reacts with ammonium salt, then produce a salt. What salt? This calcium will go and join with chloride to form calcium chloride as a salt. Then the second one is water, and the third one is what is ammonia gas. So this ammonia gas is what is produced. So this is what is your third property. So then if you know the sequence, if you know what exactly is happening, any ammonium salt alkali, then immediately you should understand, okay, three things produce, one salt, one water, and the third one is ammonia gas. So then here I may give any alkali. Instead of calcium hydroxide I may give you ammonium hydroxide, I may give you sodium hydroxide, any alkali may be given to you, or any ammonium salt. Instead of chloride I may write ammonium phosphate, ammonium sulfate, any ammonium salt, but the product will be the same. Only the salt will be different depending upon what you have taken here as an alkali or as an ammonium salt. Only this will be different, but the other two will be always same. Then the fourth one, you have one very big chapter. I think after this chapter something which is called analytical chemistry, one chapter name. Your whole chapter is about this fourth property of alkalis. Now what is that? Alkalis will be able to precipitate. Precipitate means insoluble salt formation. So alkalis will be able to precipitate. Okay, so let me not write about color and all. Will be able to precipitate soluble salts of heavy metal. Now a soluble salt of heavy metals will be able to precipitate. Now precipitate means a very colorful precipitate will be formed. Precipitate means that very thick curdy kind of substance will be formed in the test tube. So that is what is about your precipitate. So by looking at the color and by also looking at the solubility of the precipitate, you will be able to understand which cation is present in a particular salt. Again I am repeating that, again you will understand it better in that chapter, analytical chemistry. And analytical chemistry is total, I would say it is your practical. So I will try to show that that chapter, our next chapter, fourth chapter, through practical, maybe a video in the lab. But as such, what is a precipitate, what is the color of the precipitate and all, you will be able to understand it better if you have like after doing that chapter. Alright, let me now take one alkali. Let me take sodium hydroxide, and I want to take any one salt, a heavy metal, copper sulfate. You can see I have taken a soluble salt. Copper sulfate is a soluble salt, and it is a very clear solution, blue solution. This is very nice blue solution. This is also a clear solution. When you add this into this, immediately, even when 2-3 drops are going in, immediately you will find that the reaction between the two takes place to give you copper hydroxide. So this copper hydroxide is the precipitate. Immediately a curdy kind of substance is formed there in the test tube, inside the test tube, and that is what is a pale blue precipitate. The precipitate color will be a pale blue precipitate. That curdy kind of substance will be pale blue in color. So that means you can see something which was totally soluble, very clear solution. Now when you add this to, you know, a precipitate, a curdy kind of substance is what is formed in the test tube. Yeah, by the way, copper and hydroxide. Now sodium will join with sulfate to form sodium sulfate. So here it is, sodium sulfate. So this is what is your property, fourth property. Again I am reading, don't worry, even if you didn't understand this one, don't worry. Our next chapter which is there is totally based on only this fourth property, analytical chemistry. And analytical chemistry is all about your practical. So I will try to show you through practical work in the lab what this actually is. These are your 4 properties of bases. Yeah, now after acid and base, now the next section that you have, a small section that you have, is how to distinguish between an acid and a base, or what chemical test should you carry out so that you will understand whether a given solution is an acid or a base. And that is why our topic is the test for acidity or alkalinity of a solution. Now there are 2 type of tests we can call it as. One is what is using a common indicator, and the other one is by using universal indicator. Now common indicator will tell you whether it is an acid or a base. Now common indicator, there are 3 types of common indicators. They are litmus, so 3 kind. What they are? So one is litmus. Now there are 2 kind of litmus, you know, that one is a blue litmus and the other one is a red litmus. So we test with red litmus and blue litmus. Then the second one is methyl orange. So as the name itself is suggesting, it is orange in color, orange. So it will turn to some other color. Then finally the last one, phenolphthalein. Now in this phenolphthalein is colorless. By the way, let me also tell you what original color is. This is both red and blue. This is orange in color. This is colorless. Okay, this is what is the original color. Now what happens in an acid and what happens in a base? Now you have to remember this, by the way, you can learn this one. Now litmus, when you are putting a red litmus in an acid, nothing happens, but when you are putting a blue litmus in an acid, blue litmus will turn, blue turns red, and similarly in a base opposite happens, red litmus turns blue. So litmus is a solution, but for convenience, you know that solution is converted into a paper, litmus paper. You people might have seen the paper, litmus paper. So paper is for convenience, but or else, you know, all these 3 are solutions. We usually prepare a solution of all these 3. Okay, orange color of methyl orange. A methyl orange is orange in color, but this orange color will turn pink in acid, but it turns yellow in base. So orange color methyl orange will turn to pink, but it turns yellow in base. So pink in acid, yellow in base. Phenolphthalein. Phenolphthalein is colorless, so it remains colorless because there will be no change in color taking place in acid. So if you are adding a phenolphthalein in acid, nothing happens. But a phenolphthalein when added to base, it turns pink. So now pink, one is methyl orange pink in acid, but phenolphthalein is pink in base. So now see this, you have to learn this, you have to remember this. In acid also is required. By the way, this is also a properties, physical properties of acid. How actually indicator, what is the change in the color of the indicator, common indicator in acid and base. So litmus, you can see opposite, one is blue to red, that is in acid, and the other one is red to blue in base. Then orange color of methyl orange turns pink in acid, but it turns yellow in base. And phenolphthalein will remain colorless in acid, but it will turn pink when it is base. Okay, this is common indicator. Now this will tell you whether a given solution is acid or base. But if you are asked to distinguish between two acid, for example, you are given two acid, acid 1 and acid 2, and you are asked to identify the two acid, then you will not be able to, because if you use indicator, any indicator, if you use a litmus, here also blue will turn red, here also blue will turn red, so you will not be able to identify which acid is what. Then if you use methyl orange, same color change will take place in both. Phenolphthalein same, no, it will not change color. But if you want to identify between the strength of an acid, different, because one acid is stronger than the other one. To identify that, now we have a scale of measurement of acidity or alkalinity. How strong an acid is or how strong a base is can be measured by this scale. And this scale was actually devised by a chemist called Sorensen, and a long time back, and then it is something again which is a very effective scale in measuring the strength of acid and base, and that is what is called pH scale. Now P here is standing for potenge. Potenge actually means power. So power of hydrogen ion. So now I can say that this actually means power of hydrogen ion concentration. So we are actually measuring what is the hydrogen ion concentration. The more the hydrogen ion concentration, then we say more acidic it is. Lesser the hydrogen ion concentration means there will be more hydroxyl ion concentration, means more basic nature it is, or less acidic nature it is. Now then how do you define a pH? Now I am defining what is pH. pH is defined as negative log to the base 10. Now you are familiar with log, in class 9 you have seen. Negative log to the base 10 of hydrogen ion concentration taken in 1 mole per liter. So in 1 mole per liter, what is the total number of hydrogen ion concentration? So that very measurement of hydrogen ion concentration is what is called pH. Okay, for example, in one particular solution, let's suppose the total number of hydrogen ion concentration is 10 to the power minus 3. And do not forget, the total number of hydrogen ion concentration and hydroxyl ion concentration in a solution is 10 to the power minus 14. The maximum which is possible is only 10 to the power minus 14. This two. Because in water, if you are talking about water have hydrogen ion concentration of 10 to the power minus 7. Whereas hydroxyl ion concentration is also 10 to the power minus 7. Now if collectively, if you are multiplying this 2, it becomes actually 10 to the power minus 14. So this is what is called ionic product of water. Ionic product means multiplication, ionic, ions of water, because don't forget our water has this hydrogen ion as well as hydroxyl ion. So that means ionic product of water is 10 to the power minus 14. So that means if I say here in this solution hydrogen ion concentration is 10 to the power minus 3, means it is understood that hydroxyl ion concentration is 10 to the power minus 11. So total should come minus 14. So 10 to the power 11. So since we are here discussing about hydrogen ion concentration, because pH in higher classes, in class 11 and 12, you learn also about something which is called POH. So I don't want to confuse you by telling you now about POH and all. So we'll concentrate only on hydrogen ion concentration. Now, so supposing if this solution has hydrogen ion concentration of 10 to the power minus 3, then what happens to the pH? Now let's see pH. I am calculating the pH. pH is equal to negative log to the base 10. Hydrogen ion concentration is 10 to the power minus 3. Okay, you all know that by power law, this 10 to minus 3 can be brought here in front. It is minus already 1, then one more minus 3 here, then we have log 10 to the base 10. So minus and minus is plus, so it is 3 into, and you all know that log 10 to the base 10 is 1. So that means pH value is what is 3. So that means this solution which has hydrogen ion concentration of 10 to the power minus 3, which is large, and don't forget minus 3 is large, minus 14 is less, minus 11 is less, because lesser the number power with negative, you know, bigger the value will be. So that means pH value of this solution, that solution in my example is what is 3. So this solution had devised a scale, pH scale going from 0 to 14. Why 14? You have understood, because the total ion concentration is till 14. Ionic product is 14. That's why the highest scale, pH scale is 14. Now I'll just give you a small idea about what that pH scale is all about. Okay, now different acids and bases, they have different pH ranging from 0 to 14. Now we measure it, as you know that with respect to the hydrogen ion concentration. More the hydrogen ion concentration, you will see acidic. That is why by looking at the pH only we will identify whether a given substance is acidic or basic. Now how do you identify anything? You know, 7 I told you about water, so that means it is neutral. So as you move towards from 7 towards 0, you know, acidity or acidic nature, acidic property increases. That means 6 is acidic, but 5 is even more acidic than 6. 4 is even more acidic. 3 is even more acidic than 4. That means the lesser the number, smaller the number, the more acidic that particular solution is. 1 is said to have very highly acidic property. So 1 is more powerful, strong acid as compared to that which has 3, because 3 is also acid. Till 6.9 we can say they are acid. Here, the more left you move, the more stronger the acid becomes. Same way from 7, if you move towards 14, alkalinity increases. So that means 8 and 9, both of them are alkaline, both of them are base, but 9 is more basic as compared to 8. Or 12 is more basic than 11, or 13 is more alkaline as compared to, so that means 14 is the highest alkalinity property, strongest base you can call it. So look at the arrow, from 7 it's separating, 7 is neutral. This is what is considered as neutral. Neutral means neither it is acidic nor it is base. Water has a pH value of 7 because it is neutral. It has equal number of hydroxyl ion and hydrogen ion. That is why it has a pH value of 7. Now then, how do we find out this one? So litmus or a phenolphthalein or a methyl orange will only tell you whether it is acidic and base. Now to understand the pH value of different solution, we have another indicator, and that indicator is what is called universal indicator. A universal indicator also changes color, but it changes to many different color depending upon the pH value of that particular solution. It is not about red to blue, blue to red, or to pink, or this one. So many different colors will be there. So now it will be easy for you to remember the color. Now see what color changes will take place. Okay, so where I'll write. Okay, so let me write here. Okay, so here it is, the rainbow color. You know that Bibgyor, Bigyor. Only thing is that your orange is what is turned to pink. That is the only change that you see. Or else all colors are the rainbow color, the color, same color that you have learned in physics. Okay, now that means what kind of indicator is a universal indicator? Like usually when a universal indicators are of two kinds, one is a solution or the other one is in the form of paper. Same, for convenience we have a paper. Like if I tell you about a universal indicator, a small strip of paper is there, almost which is looking almost of the same size of that of the litmus paper. But on the cover of that universal indicator, this kind of boxes will be there, where this kind of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, and all boxes are of different colors. Yeah, these colors, different colors. Some a little shaded darker. For example, you may say, sir, only 7 colors are there, but you have 14. And how? Because maybe of same color, maybe a little darker, a little lighter. So that way, 14 colors is what you will see. Like for example, you are finding the pH value of this particular solution. Then what do? Take the universal indicator paper, dip in this and dry it. Once it is dried, it will have a color. Then what you do? Match which box is matching the color of your universal indicator. You match it now. Suppose if it is matching, the 10th one is matching. This box's color is matching with the universal indicator color. Then it is understood that the pH value of that particular solution is 10. That is how universal indicator works. Again, universal indicator has this is what we can call is a key color, a small strip of paper which is given to you so that you can match your paper, match your indicator, match your universal indicator paper, and then whichever color it is matching, so based on this one, you can say what is the pH value. Now finally, one more section is left now, that is what is about uses of acid, bases, and also uses of pH. Now they are all very simple and easy. They don't require too much of an explanation. They are very easy to understand. I'll put it there maybe in the video, or maybe I'll give you in the form of a download link the uses. Like for example, where acids are used. Now you may say where acids are used. Acids are used only in the batteries. You may only think of, but so many different uses of acids are there. Same way bases are there. You'll be surprised to see that some uses of acids and base are so common that we have been using it, but we don't know that you're using an acid or a base. So since the video has gone very long, so I think I'll just put a download link or maybe in the video I'll put it. And similarly pH has a lot of significance in the field of in let's call it as medicine or in industrial uses, even so much so that even in agriculture, like for example a pH of the pH scale of a soil, because one particular crop grows better in a one pH, acidic pH or a basic pH, or acidic medium or a basic medium. For that also, so many in dairy products, dairy farming, that pH, and so much so that that even your diseases, sickness can be identified. You might have heard about your urine tests. Even in the urine test or in the blood test, the doctor will ask for a pH. If you have seen the blood report, there you will see that pH of the blood, pH of urine will be written. So why it is? Because the doctors will be able to find out with your pH what infection you may be suffering from or what disease you may be suffering from. So lot of significance is there. Now we have finished with acids and base and as well as pH. Now only one part is left, and that is salt. And salt is the one which is the most difficult part of this chapter, and especially preparation of salt. Our next class will be that preparation of salt, but that part is a little lengthy. Maybe that also I have to divide into two parts, or maybe if possible I'll finish it in one video. Till that time, goodbye and thank you.